changing. There's a lot of investments also in the trucking industry, also in rail with electrification, cleaner technologies. Also, the sourcing of the electricity is improved, which means that in comparison to inland waterway transport, other modes of transport are, let's say, greening more rapidly than the inland waterway transport sector. So there's a need to also focus within the inland waterway transport sector to apply green technologies to remain and keep a license to operate. And that does not only affect, let's say, the carbon footprint in terms of CO2 emissions, greenhouse gas emissions, but especially also means that we have to look at air pollutant emissions, like I mentioned, nitrogen oxides and particulate matter. If we look at inland waterways, they are connecting, let's say, ports and hinterlands, and a lot of communities, cities, towns are located right on the rivers, on the river banks, on the banks of inland waterways. And well, in comparison to greenhouse gas emissions, which affect climate change, air pollutant emissions directly deposit close to the area where they are emitted. So here you see an example of a graph in China from the Yangtze River, where you can see the nitrogen emissions intensity on a scale, and see that they are directly on the banks or at the banks of the river. So that means that that inland waterway transport might be a champion in terms of carbon intensity and energy use per transported kilometer or per ton kilometer. In air pollutants, there's quite a gap, and the emissions are quite high, as you can also see on a photo, on a picture on the right-hand side of a passenger ferry in West Bengal, India, where let's say the tailpipe emissions and the soot are clearly visible, which causes all kinds of impacts to both human life and aquatic life and the environment close to the river banks in the hearts of the community. There are quite some developments internationally how to address this. For instance, in Europe, the high level of air pollutants of inland vessels has led to specific regulations, higher emission standards for new engines that are built in existing vessels or as part of new vessels. You see that in comparison, these emission standards are of European stage 5 and also US tier 4 are very strict. For instance, in comparison to other inland waterway systems that are very developed, high developed, such as China, which has lower emission standards. In India, these emission standards, marine engine emission standards, have been improved in the last few years, but are still, let's say, of the level of IMO tier 2. I think the developments in Europe are a good thing. At the same time, we have to realize that new engines that have been developed by engine manufacturers complying with these new emission standards achieve these levels, but are twice as expensive as the previous standards, which is at the level of China stage 2. So yeah, it comes at a cost. In terms of decarbonization goals and strategy in Europe, a greening strategy has been developed, where, let's say, on the right-hand side, in the blue areas, we make use of the intrinsic merits of inland waterway transport as being a clean, efficient mode of transport, which has a lot of spare capacity to transport goods on the waterways, whereas roads are heavily congested. So we want to achieve a model shift from road to waterways. So we want to improve IT tools to support this model shift. We also want to look at new markets to be developed on inland waterway transport, and we look at new vessel concepts in terms of automation to even increase the efficiency of inland waterway transport solutions. Then on the left-hand side, which is also more the topic of my presentation today, we see all kinds of solutions in relation to research and development and pilots and application of alternative fuels. Also air pollutant emission reduction with after treatment systems, and also look at the vessel itself to improve the energy efficiency and to look into other let's say propulsion drivelines, but also, let's say, improve the hull shape of the vessel to reduce the energy use, the resistance in the water, to increase the energy efficiency. Some examples, and this is quite interesting to illustrate, is that also digitalization can really support the greening process. Is if you collect data on board of a vessel and look at the operational profile, and you do this for a full year. We did this on a number of vessels in the Netherlands, and we actually saw that let's say 50% of the installed power on board of that vessel wasn't used, and this is basically fuel gone to waste, but also money going to waste, and also can lead to quite significant CO2 savings. In this case, a 135-meter inland container vessel could have saved more than 50,000 liters of diesel, with, well, against a value of approximately $60,000. And that's basically money in the pocket of the operator, but also this money can be used to look into alternative energy sources, new propulsion drivelines for this vessel to transition to greener technologies. And in this transition to greener technologies, this is basically the issue that we have to solve. In comparison to diesel, the next best alternative energy source is methanol, and still based on the volume factor and the packaging factor, so the energy density and the packaging on board of the vessel. Still, if you use methanol instead of diesel, you need 2.3 times the same amount, 2.3 times more methanol than diesel to transport cargo for the same distance. And well, you see there also for hydrogen, for battery electric, the situation is even worse. So this is, although there are alternatives available, this is a challenge that we need to resolve. And if we can improve the energy efficiency of the vessel itself, then also the transition to alternative fuels may become a bit more interesting and more feasible. There are solutions. So I mentioned the emission stage 5 emission standards in Europe. Engines have been developed and have been brought to the market. Marinized engines, non-road engines, also converted truck engines with even higher emission standards are available, but against a higher cost. Combined with biodiesel, they can even get to near zero emission. So options are available already nowadays to transport goods in a climate neutral way on inland waterways. This is a very interesting concept with battery electric solutions from zero emission services, where the operator does not have to invest in the technology, in the battery packs. This system works on a pay-per-use system, so the operator pays for the per kilowatt hour of energy that is consumed on board of the vessel. So there's a consortium with a port authority, with a technology provider, with a bank, and they have developed this concept to also receive some subsidy for this, for the outroll of this concept. And this is happening, and there's also this is being scaled up on inland waterways in the Netherlands and in Europe on the basis of exchangeable energy containers. Now it's battery electric. In case of the hydrogen fuel cell technology becoming more cost efficient in the future, you can also use a hydrogen concept in these kinds of containers, because the propulsion drive line is modular, and as long as the output is electricity, any source can be used inside of a container and is plug and play. Also hydrogen fuel cell technology. There's a few examples in the Netherlands, in Europe, where this has been applied. Again, higher capital cost, higher operational cost. These vessels received a subsidy, but also some, let's say, shippers that are interested from a marketing perspective for, let's say, and also have a corporate sustainability responsibility. They also co-invest in these kind of solutions to transport their goods in a green way. In China, a lot of practices. The emission standards are still lagging a bit behind, but in terms of transition to other alternative fuels other than diesel, you see quite some developments. Still, LNG is considered as a transition fuel towards greener technologies, and there's a lot of developments in terms of all-electric, battery electric vessels. More than 280, I would say nowadays, or more than 300 vessels in total, which also includes the smaller vessels, but you see also larger vessels are increasing in terms of all-electric solutions, application of all-electric drive lines rapidly. Then there's a lot of research and developments in terms of ammonia, hydrogen powered vessels, and also methanol. Few examples. COSCO has now 2 vessels in operation on the Yangtze River, which have container vessels which have a capacity of 700 TEU. And out of those 700 TEUs, they have 36 TEU capacity to install battery packs, exchangeable battery packs, so swappable containers, with a total capacity of 57, more than 57 megawatts, a megawatt hour. They can transport, they have to transport containers over a length over a distance of 1,100 kilometers. And during this trip, going upstream, they have to exchange all the batteries twice, and they do it a single time, only once going downstream. And then on top, you see a inland dry bulk vessel that ironically transports coal over a distance of approximately 250 kilometers. And this vessel has fixed batteries and has a range of 300 kilometers actually. But to illustrate that the source of the electricity is very important in the transition to zero emission, because if the source of the electricity is thermal power, so coal, then we have to be honest about the emissions from a well-to-wake supply chain. And it's actually more polluting than if you would use diesel for the same trip. Obviously, if you use renewable energy sources such as wind, solar.
Mr. Richard,
Yeah,
please wind up in 1 minute.
sure, will do. We have to, then it's actually zero emission, of course. Then for the USA funded project, we looked at the Indian inland waterway transport market, and here we saw a big opportunity because there's only a limited number of vessels registered in India that operate on the Indian waterways. Mostly transport is being done by vessels from Bangladesh. So this opens a new opportunity to design and fund new vessels. And we have to do it in an energy efficient way because these vessels operate and they have a very long lifetime. This is the objective of the USAID financed study. We are in the process of designing 3 vessels. The contractor is Nevalt, who is also, I think, present today in the audience and will give a presentation. 3 designs. One is a RoPax vessel, which is solar battery powered, completely zero emission. The other 2 vessels are bunker and tanker vessel. I will only show you this design of the tanker vessel, but the bulker vessel has the same characteristics and uses a wide range of technologies. Also, let's say battery packs, solar panels, but also it's also wind assisted sailing, and this provides this vessel a range of approximately 250 kilometers to sail zero emission. Then there's backup diesel generators to extend the range to transport cargo on National Waterway 1, 2, 5, 16. This is modular. So as soon as there's another solution, whether this is hydrogen, methanol, ethanol, produced in a green manner, we can exchange the diesel generators with an alternative solution. So it's also a future-proof design. The next steps in the study is that we will focus on CFD modeling. It has been done within the firm Nevalt, but we will also have an India-based institute that will look into CFD modeling for shallow water conditions. And we will also have an international institute doing experience in shallow water conditions and CFD modeling and scale model testing to test the hulls of this vessel to make it super efficient. Then there's also capacity building for the India-based institute to gain more experience in terms of shallow draft designs. And then we will finalize the designs and go for IRS approval. Then in parallel, we work on the business case development to seek a shipper that is interested to use these vessels in their daily operations and work on the financing together with the India government, the Ministry of Port, Shipping and Waterways, and the Inland Waterway Authority, together with banks, and also work on a guarantee system to de-risk the investments of banks into the inland waterway transport sector, and hopefully come to a sound business case to actually build these vessels. Then my last point is that in spring next year, let's say around March, April, there will be a roadshow in India and Bangladesh to showcase these designs and discuss opportunities for green inland vessels. And we hope to also be able to use the participants and invite the participants today to work together also with Frost, the Frost platform, to have you also on board and see you also at one of these roadshows that will be organized in India. That's it from my side. Thank you very much again for the opportunity to speak to you today. If there's any urgent questions now, I'm available to answer them, and otherwise, please reach out. I will be happy to answer any questions now or later. Also, Mr. Dandapat and Mr. Solanki are in the audience. Also, Mr. Sandit Tandashari, who is involved in the study. They can answer detailed questions about the work and the designs. Thank you very much.
Thank you, Mr. Richard. Because of paucity of time, really no question from the audience. They may contact you through your mail ID or other means. Otherwise, it was a very interesting talk where you are talking about the decarbonization leading to greenfield, and you have shown how world and various people gone approach, and you have a plan to further India also. I hope this project will be successful. Thank you very much.
Thank you.
Last presentation by Subhakar Dandapat. The topic is on a vibrant inland navigation system for regional connectivity and better initiatives in Eastern South Asia. Bhutan, Bangladesh, India, especially the East and the Northeastern region, and Nepal. So firstly, I introduce Mr. Subhakar Dandapat. So he has done his BTech honors in naval architecture from IIT Kharagpur and MSc in ship production and technology from Strathclyde University, UK. So he is an expert on inland navigation and naval architecture. And he is currently associated with the World Bank Group and the United States Agency for International Development for greening of inland fleets in India and Bangladesh, as well as implementation of the World Bank sponsored project on IWT in Bengal for strengthening the ferry and fleet services on the Hooghly River in the Calcutta metropolitan area with the required infrastructures. So Mr. Dandapat has commenced his career at Hindustan Shipyard Limited and superannuated from the Inland Waterways Authority of India. So as a post-retirement assignments, he has provided consultancy services to the Adani Port and SEZ Private Limited, then the Hub Engineering Project Private Limited for the execution of the World Bank funded project, JMVP on NWI, and CUTS International Limited. Okay, so with this brief introduction, I welcome Mr. Subhakar Dandapat, please.
Good afternoon to everybody. Anyway, everybody is talking about greening up the IWT sectors, but it is also important that waterways, whatever the existing are also fully developed, so that the greening of IWT sectors in terms of the vessels can also be implemented in toto. So that's why my topics will be mostly the Indo-Bangladesh protocol routes connected with NW1, NW2, NW16, and NW5 is not yet connected unless it is developed fully, and then East Coast Canal is connected to NW1 and NW2. Sorry, Bangladesh, Indo-Bangladesh protocol route. So this is that waterway systems we are talking about. This was in fact conceptualized by World Bank. This is called the Inland Waterways, Eastern Waterways Grid with NW1, NW2, NW6, 16, that is Barak River, and Indo-Bangladesh protocol route. Indo-Bangladesh protocol routes, there are 10 protocol routes are there, total 2,781 kilometers I hope. And that times they have not considered NW5 because it was not developed, and so now we have suggested them that why not you should consider NW5 also. So NW5, this river portions, of course it is being developed, it will be developed very soon. Minister is coming over here to give some good news about it, but East Coast Canal systems has been neglected and it should be developed, and state government or our here there should be some pressure on this aspect as well for developing East Coast Canal systems. This is the Indo-Bangladesh protocol, and this has started from 1973. In fact, this waterway is there for the time immemorial. I mean, even before we got the independence. That times there was no restrictions, there was no protocol, there was no rules and regulations in the British times, Mughal times, and even earlier also. After the independence of India and then Pakistan's, and then subsequently Bangladesh, a lot of restrictions have come up. So with this 1973 protocol, and right now there are 10 routes of 2,941 kilometers, out of which 1160 kilometers are in India, 1750 are in Bangladesh, and there are 14 ports of call in each country, and it is being renewed every 5 years. Cargo is shared by 50-50%. That means vessels also will have to be 50-50%, but in practically it has become nil in certain cases. In certain cases it is 5% only from Indian sides, and rest of the vessels are from Bangladesh. The reasons are very obvious, which I'll come subsequently. At the moment, the EXIM cargo on the IBP route is almost 4.75 million tons. That is in a CAGR rate of 10.6. And whereas the transit cargo, that is the cargo from mainland to the northeastern regions, it is only 2.75. And the CAGR rate is hardly 7.6. And the commodities are mostly the stone chips, fly ash is almost 72%, and the rest of the cargoes are containerized cargo is very, very less. In fact, there is no container vessels for that route. Whatever the vessels are there only in Indian sides. Bangladesh vessels are not at all suitable for carrying any container vessels or even ODC or even for high value cargo like steel product or steels and all. So therefore, here only the Indian vessels are used. Then while we talk about this, why the IBP route is so important. It is important mostly for the chicken neck corridor of the East Siliguri. That's the then economic growth of the northeastern regions, increased trade and investment between India and Bangladesh, increased modal share of IWT being the cheapest. That's the things I have shown it, because at the moment IWT itself is around 9% in that eastern, southeast, that is between Nepal, India. India means only the eastern and the northeastern area.